Okay, so we'll talk about confidence interval. Confidence interval is the upper and lower boundary. The bounds are estimates. It increases our confidence that the estimate from our statistics are close to the truth and not as a result of mentions. It's just simply explaining that researchers, confidence interval from the name confidence simply explains that researchers are confident that their estimates fall within this, their estimates fall within a particular upper and lower boundary. So let's go for that so that I'll explain better. So most academic research is a 95% confidence interval, meaning that 95% of the time researchers are confident that their estimates fall within upper and lower boundary. So I just want to state before I start explaining that 95% confidence interval is not the standard, that some researchers use 99% confidence interval in clinical trials and based on how delicate their study is. So basically what this is explaining is that researchers are, okay, let me annotate for better understanding. Just, let's say if a researcher sets his confidence interval at 95% and he wants to assess the prevalence of hypertension, that's hypertensive individuals in Rivers State, and he gets a prevalence rate of 4.87% with a 95% confidence interval of say 3.67 to 5.78. So now this 4.87% is the best estimate that our analysis gave us when we ran the analysis in our SPSS. It gave us that 4.87% of individuals are hypertensive in Rivers State. But then we are 95% confident that if you run this analysis again and again and again, that the prevalence rate is going to be between 3.67 to 5.78. And you can see that 4.87 is contained in our boundaries. It's contained between the upper and the lower and the upper boundaries. So this 95% confidence interval increases the confidence of the researcher. The researcher is telling you, or if you read the paper is telling you that that variable that signifies that that variable is with the confidence interval. The confidence interval explains that that variable 95% of the time when you assess that variable in a particular region or whatever setting they set the paper in, 95% of the times you will find that that variable is contained within those boundaries. That is just confidence interval. Let's continue. What is alpha value? And our alpha value is simply the threshold. That is the maximum level of risk a researcher is willing to take. It is a threshold value we measure the p-value against, and it's also known as significance value. So the alpha value just explains that if we set our alpha value at 0.05, which is also in percentage of 5%, it means that our confidence interval is 95%. So it's just simply telling you that this is the level, the highest. So it's just the alpha value just simply explains to you that this is the maximum level of risk the researcher is taking, that anything that exceeds the 0.05, the researcher is not willing to take it. It's going to say that, okay, this test statistics is not significant. And since it's not significant, it might mean that it could be due to the probability that this event is occurring in this data. It could be due to chance, and this chance will be as a result of sampling by a small sample size or convenience sampling. So the 95% confidence interval, it's giving the researcher that confidence that his estimate 95% of the times will be correct, and then the alpha value is the maximum level of risk. And so anything that exceeds that the researcher is not willing to take it, it's going to call it non-significant, and that is basically it. So just to read this, an alpha value of 0.05 means that the level of risk the researcher is willing to take is higher than the set value of 0.05. Therefore, the probability of that event happening is due to chance and not the information conveyed by the data. And chance could be as a result of sampling bias or small sample size. Okay, so p-value is also known as the probability value, and it is identified as SIG in SPSS. So I think I just want to run the analysis. Okay, let me show you guys this report. From this report, you can see that it's comparing the levels of glucose, peroxide dismutase, and glutathione between diabetics and non-diabetics. And basically what this is in this analysis, there are 30 cases and 30 there are 30 cases and 30 controls. That's 30 non-diabetics. So from here, let's say we are running these reports from the beginning. We don't know whether glucose is parametric or and glutathione is not parametric. We don't know whether our sample is drawn from a normal distribution. So what we are going to do is that we open the data. Okay, so our cases is signified, there are controls, 30 cases, 30 non-controls. And if we check here, that means it's 1. We coded our cases as 1 and our controls as 2. We check our variable view, you can see that our value is already coded, and that's why it's showing like this. So now to check if our glucose is parametric or non-parametric, I like to go with the graphs first, legacy dialogues, histogram, then my glucose is already in, but let me uncheck it. So I put in my glucose. I want the normal curve to show. So I click on display normal curve, which is already ticked. I press OK and show my output. Excuse me. Okay, so this is the output showing. Okay, yeah, so this is the output, and you can see from here that this is a rightly skewed data from what we've talked about in our previous video. So this is a rightly skewed data. This one is quite evident, but there are sometimes you run your graph, your histogram, and then you don't, it is in between. You don't know whether it is right normal distribution or it is a skewed data. So in that instance, you just go further. But since this is already shown to us as non-parametric, let's still use our Kolmogorov testing for better screening. So we go to analyze, we go to non-parametric test, we go to legacy dialogues, we go to one sample. Glucose is already in, but we'll uncheck it, we put in our glucose back. The normal, we want a normal, we tick on the normal, we press OK. From here, you can see that our p-value is less than 0.05, meaning that our data is not normally distributed. So since it's not normally distributed, what do we use to represent? For better representation, we use the median and interquartile range. So we go to data first, because it is 2 groups. We want to split, we want to get the median and interquartile range for the cases, median and interquartile range for the controls. So to split our data into the 2 groups, we go to data, we go to split files, then we go to organize output. This is our SN, but we unchecked it, we are putting it back. We press OK. It shows sort cases by serial number below. Then we can do our descriptives. We go to analyze descriptive statistics, frequencies. Glucose is already in. Statistics, we already see that it is non-parametric, so we use our median and interquartile range instead of our mean and standard deviations. Already tick, but let's just do it for 26. So this is median, this is quartiles. Then continue. We don't want our frequency table, so we just press OK. And this, you can see this is a median and interquartile range for cases, median and interquartile range for controls. So our median for cases is 6.05, median for controls is 4.5. So let's go back to the report and you see how we reported it in APA format. So you can see this is 6.05 with the percentiles in bracket for the cases, 4.50 with the percentiles in bracket for the controls. For the p-values, we use the independent sample t-test, which I'll come back to later. But you can see that our superior oxide dismutase is already non-parametric because of the way we reported it here. So let's just do another one, glutathione, which is, let's say that we don't know whether glutathione is parametric or not. So we go back to our SPSS. Then when you split file, always on split. I always do this mistake. And then when I get my result, oh, I'll not be like, oh, I did not on split. So please always on split when you split your files. Okay, so we want to check, go to graphs, legacy dialogues, histogram. Where's my computer? Histogram. Okay, then we put in our glutathione. Our display normal curve is already clicked, so we press OK. Let me share my screen. And this is what that means. This did not on split because it's giving me graphs for cases and control differently. So why did it not on split? Okay, it's real now. So let's run the graph again. Histogram, just this. We go. So you can see that this is, to me, this is slightly looking left skewed, but then if you look at it again, it is normally distributed. So that's why I just like using my non-parametric test. So you analyze non-parametric. That's why I like using my Komogorov for my normality testing. So we go to analyze non-parametric test, legacy dialogues, one sample cares, we uncheck glucose, we put in glutathione, we tick normal, we press OK, and you can see our p-value is 0.832, meaning that our distribution is normally distributed. And so since it is normally distributed, we use mean and standard deviation. So we go back to our data, we split files because we want to get the mean of the individual groups. We split files by serial number, we press OK. The sort cases is on, we go to analyze, descriptive statistics, frequencies, we uncheck glucose, we check glutathione, we go to our statistics, we don't want median and quartiles again. Now we want standard deviation and mean because it's a parametric test. It's a parametric, it's a normal distribution. So we don't want frequency table. We say okay, and then this is the mean and standard deviation of the several of the two cases, of the two groups, cases and controls. Mean 27.71 for cases, mean 32.86 for controls with their standard deviations. So we go back to the report and you can see this is how we report it. So to get our p-value, we use independent sample t-test where we want to compare between two groups. So let me show you how I generated this p-value. Then from there, I explain confidence interval, and that will be it. So go back to our data, check. Okay, so this is, we've unsplitted now. So back to our data, analyze, compare means one sample, independent sample t-test. We click on glucose. Okay, you know what? Let me do this. So that's, okay, now this is what it is. Now we we click on glucose for the test variable. I want to group by serial number. And you can see the question mark and the question mark. You press your define groups. We do find our group as 1 for cases and our controls as 2. You press continue, you press OK, and a whole lot of things come up here. This is the table for independent sample titres. The person that will teach independent sample titres will explain this table better, but my concern here is the 95% confidence interval. And as you can see, I just want to say that you can use your confidence interval to know whether your statistics is significant or not. So now in a number line, you have 0, and to the right, you have 1, 2, 3, 0 to the left, you have -1, -2, -3. Now, I just want to say that if your confidence interval, that means from the lower boundary to the upper boundary, passes through the 0, that passes above the 0, your test will not be significant. But if it's towards one side, either the right or left, your test will be significant. Say your like example now, what is on the screen, you have 1.5 and you have 4.0. It's not passing the 0 mark, the 0 point, it's just to the right of the 0. So your test will be significant. Say your lower is -3 and your upper is -2. So far it's not passing above that 0 point, your test will still be significant. So please take note. So this is 0.0000 to infinity. And so when we want to report it, we say that our p-value is less than 0.001. So this is the report. Okay, so this is our p-value less than 0.0001. And then if you want to interpret it, you can see there where I wrote non-diabetics within median and interquartile range had a significantly lower glucose level than diabetics. Now let's run for the p-value for glutathione. Let's go back to our statistics. We're going to analyze again. I'm just doing this so that it will sink in better. Compare means independent sample titres. We uncheck glucose. We put in glutathione and we press OK. Okay, so let me okay, so this is our output for the glutathione we ran, and as you can see, this is -10 on the lower and 0.5. So it moves, it crosses across the 0 marker. So that is why our p-value is greater than 0.05. Here, our p-value is 0.077. So I really hope you understand how our confidence interval affects our significance. Remember, the 0 mark, if it crosses whatever value, if it goes from minus to plus, it will not be significant. But if it stays either on the plus side, there's the both boundaries on the plus side and the both boundaries on the minus side, it will be significant. So sharing the report, you can see we said that there is no significance difference with a p-value of 0.077 in glutathione levels between the both groups, cases and controls. So that is simply it on confidence interval, alpha value, p-value. So just a recap, confidence interval, most times researchers use the 95% confidence interval, and confidence interval just simply boosts the confidence of the researcher, stating that 95% of the times, if you run that, if the estimate of that variable again and again and again, 95% of the time, the values will be within this lower and upper boundary. And then the estimates that's in front of that's the best estimate is what the statistical analysis could give. Then the alpha value signifies the level of risk, the maximum level of risk the researcher is willing to take. Anything above that 0.05, the researcher calls it non-significant and is not willing to risk up to that level, saying that this probably the relationship or the association between these two groups are not significant, and this could be due to chance or sampling bias. That's due to chance, which could be due to sampling bias, convenience sampling, and a whole lot of things that are involved in statistics. So then your confidence interval can be used to predict your statistical significance. If it crosses the 0 point, you know that that p-value is not going to be significant. If it's either to the left or to the right, you know that your p-value is going to be significant. You know, before we looked at this report and we did them individually, but now I have run them as an entity, and I hope you do understand what confidence interval is and all. So thank you very much. That will be it.